Welcome to solving Advent of Code 2015 day 6. So I've solved day 1 through 5 and now we're ready to solve day 6. Let's just get going. Ooh, probably a fire hazard. So some neighbors, blah blah blah, 1,000 by 1,000 grids. Some ideal lighting configuration. So we have some lights in a grid. They're numbered from 0 to 999 in both directions. The lights are at each corner so at the 4 corners. The instruction includes whether to turn on or turn off or toggle various inclusive ranges given as coordinate pairs. Each coordinate pair represents opposite corners of a rectangle inclusive. So 0, 0, 2, 2 is a rectangle. Refers to 9 lights in a 3x3 square. Okay, so either turn a bunch of lights on, toggle them, so switching them between on and off, or turning a bunch of lights off. So we do that for a bunch of times, and then after following these instructions, how many lights are lit? Okay, sounds doable. There's a bunch of instructions. Let's just copy them, make a folder for day 6. Let's put in our input and copy the template. Okay, and let's get going. So we will start by opening the file, reading the data. So we're gonna say line.strip for line in if.read lines. We don't want the end line, therefore I'm stripping it. Alright, so the question is, can you actually do obviously I can just do a brute force way, which is what I'm gonna do. I'm gonna do the brute force, but the question is it actually a smarter way of doing it, where I can keep track of overlapping rectangles and whatnot? Honestly, I'm not sure. Obviously there are a better solution, have to do it better than that, but man, I don't want to think about it. Let's just do it brute force in the beginning, see if we have to be clever afterwards. Probably not. The first week of problems are never really that difficult. They rarely require algorithmic insight. They just require programming ability, the ability to take instructions and implement them. Okay, so our grid is a, you know what? Let's use some NumPy. So NumPy is amazing at representing arrays, which is what we have. So our array, our grid is gonna be a 2-dimensional array of size, can I remember how to do this? Full. Okay, so it's 2-dimensional array of size 1,000 and 1,000, and it's gonna be 0. So 0 is gonna represent closed off light, and 1 is gonna represent a on light. Okay, so this is our grid, and then we're gonna loop over the instructions. So what was the format of these? Advent of code day 6. Okay, so what was the turn on or turn off? Okay, so if instruction dot so what we're gonna do? Okay, so if instruction dot starts with turn on, then we have one case. Okay, if the instructions start with turn off, and if the instruction starts with toggling. Okay, so that is at least some cases I have to take into account. Then I want the corners of the arrays, so I have to alright, so what we're gonna do is we're gonna split the instruction by space. So now words is array containing, you can see shit. Alright, so if you take this instruction, so instruction, and I'm gonna split it, then we get an array of all the different words split by a space. And I know, so the problem is that depending on what instruction I have, I'm either gonna have 2 words in the beginning or 1 word in the beginning, like turn off or toggle. So I'm not gonna look at the beginning of the array, I'm gonna look at the end of the array, because the end of the array is has the same structure, doesn't matter which instruction I'm looking at. So words of -3, that is always going to be one corner. And this one corner I'm going to split based on the comma. Because if we do that, so instruction -3 dot split on the comma, then we that is because I will save this in a thing called words of -3 dot split on the comma. That gives me the two coordinates. So I'm gonna split that on the comma, and let's just call it x and y, and then we're gonna make those into integers because I don't want them as strings. And then we're gonna do the same. Let's call them x1 and y1 and x2 and y2. So those are the coordinates of the two corners. Okay, and then afterwards I'm gonna figure out what I'm gonna do about this one. Okay, so now given the two corners, how am I thinking about updating this? Okay, so let's just try and do the turn on. So I can do some nice indexing. So the rectangle is going to go from x1 to x2 inclusive, so I have to add another 1, and then the y direction is going to go from y1 to y2 inclusive, so add another 1, and it is going to turn on this rectangle, so I have to set it all to 1. In the turn off, I'm going to set it all to 0, and in the toggle, well, now I'm going to turn a 0 into a 1 and a 1 into a 0, and you can do that by saying that every value in this rectangle is gonna be 1 minus itself. This 1 minus itself will flip a 0 to 1 and a 1 to a 0. Okay, so this is it. Oh, elif. And that's it. And now we're gonna print the number of on lines, which is simply just gonna be the sum of the grid. And since it's a numpy array, maybe I should do the numpy function. And that's it. Okay, let's try the test input. So test input.in, paste in. Now we have to modify this one. And the last one. Okay, I think that is formatted correctly. Let's try and run it. So, solution, the first problem on the test input. Let's see if it breaks. Okay, something happened. Does it tell me how many I'm gonna... So turning on will turn on every light. Okay, so that's 1,000,000. Toggling this one will circle the first 1,000 lights, so that's 999,000. And then turning off 4 lights, so that's going to be 99,808, whatever it is, 1996. That looks correct. Okay, so let's try it on the input. Let's run it. And this, like, Python is actually really slow. Like, it's a horrendously slow language, but NumPy is fairly fast. Like, NumPy is pretty fast. And the reason NumPy is pretty fast is that NumPy under the hood calls low-level C code or C++ code. I don't know if it's C or C++. And that is really, really fast. So these array operations are going to be much, much quicker than doing it in a normal NumPy Python way. Maybe afterwards I can try and implement this without using NumPy, and we can see the difference. So for these kind of things where I have to do array manipulations, yeah, NumPy first of all makes it easier to implement because like it's so easy that you can make these array manipulations, and second of all, much faster than good old turtle speed Python. Okay, 1 golden star. Okay, and the next one. Blah, 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 blah. The light grid you bought actually has individual brightness controls. So now they're not just 0, 1. The phrase turn on actually means that you should increase the brightness of those lights by 1. Turn off means decrease. Toggle means that you should increase the brightness of those lights by 2. And now we want the total brightness. Okay, so essentially this is going to be exactly the same code. It's just that in this case, I'm not gonna set it to 1. I'm just gonna increase it when it's turned on. When it's turned off, I'm gonna decrease it by 1. And when I toggle it, I'm gonna add 2 to it. And now what if we reach below 0? Is there something to that? Ah yeah, to a minimum of 0. Always remember to actually read the problem. So after I have decreased it, how do I actually do the max of something? In NumPy. Now I'm getting confused. Okay, so let's make an array, np.arrange. Let's make a nice little array. Okay, so A is a 3x4, 4x3, something like that, 3x4 array. And now I want to say A is equal to the max, np.max of A and 3. What if I do that? Whoa. Okay, it could not do that. How do I do that? Max. How do you do that? How do I make sure that this value is not gonna go below 0? Alright, I did 2 minutes of Googling, and apparently there's a function called clip, where I can set a minimum and a maximum. So in this case, okay, let's just, to test it out, set the maximum is gonna be 5. And that seems to work as it should. So clipping it to 5, reduces all numbers above 5 to 5, and that is what I want to do. So now I want to take this grid. Let's just take all of it. Oh, that might be expensive. Okay, I'm only going to manipulate this grid. And, come on. Like this. And then I'm gonna clip it where the minimum is gonna be 0. Okay, I think that would work. Let's try it. To test input. I didn't print anything. So let's do that. Grid.sum. 1,000,000 and something something. Yeah, I did some Googling. Okay, so for example, idle would increase the total brightness by 1, and toggling that one would increase the total brightness. Oh, you know what? I don't want to test it. I just want to run it and hope for the best. And then cry if it doesn't work. Okay, so some big number, 14,000,000 something something. Let's submit it. Whew, thank God I don't have to debug it. Okay, so we solved day 6. Oh yeah, let's try something fun. Let's try and do this in the slow way. Solve one slow. Where I do all this, but instead of using NumPy arrays, I will, let's just keep the array, but instead of doing NumPy array manipulations, I'm gonna do slow as for loops. So for x in range x1 to x2 plus 2, there are some plus 1, there are some offsets. For y in range y1, y2 plus 1. In that case, I'm gonna say grid of x and y is equal to 1. Whoa, whoa, whoa. I am messing everything up now. Okay. In this case, I'm gonna set it to 0. In this case, I'm gonna set it to grid of x and y, 1 minus. Okay. Okay, and how do we want? Okay, and let's just do a little bit of hacking. So if n is equal to 3, then I want to solve the first one slow. And I want to time it. So let's import time. And I don't want to time reading the data, I just want to time actually doing it. So I'm gonna start at time to time. And I'm gonna end at time to time, and then I'm gonna print how long did it take. So end minus start. That's gonna give me the time difference. Let's do the same here. So start equals time dot time, and then we will end at time dot time. So I'm taking the 2 clocks of when I start, when I end, and I'm gonna print the difference. And we will see what the difference actually is. Okay, so the first one, the fast NumPy solution. Oh no, I messed up. Where did we mess up? Line 27. Line 27. Yeah, this should be a negative. Okay, let's try again. Okay, so 0.2. Okay, so about whatever that is. Okay. And let's try the slow one. Ooh, look at that. It's not even done yet. It's just, oh my god, that was like 100 times slower. Literally 100 times slower. 3.6 divided by 0.02488 something. Okay, almost 150 times, okay, slower than doing it in NumPy. Yeah, these array doing nested for loops in Python, that's just gonna be a world of pain when it comes to performance. Okay, so that was solving day 6 of Advent of Code. Another question is, can we actually do it in a quicker way? Are there so this is a brute force way. I'm not doing anything clever. I'm not keeping track of overlapping rectangles. Like, it's probably a solved problem. You could probably Google yourself, Google a way to a fast algorithm. Okay, so after thinking about it for like 30 seconds, like you can do something that probably in most cases would be faster, where you keep track of, like you split your array up into non-overlapping rectangles, where each rectangle contains the same value. So in the beginning, your entire array only contains a single rectangle containing 0. And then whenever time you get an instruction, so instruction is a rectangle, you figure out this instruction rectangle that you get, which of the other rectangles I have split my grid into does it intersect with. And only those rectangles where it intersects do I have to do some updates. And that way you can probably, you can probably make it a bit faster that way. But frankly, it's not worth the pain at this moment. Like that's probably fast enough. Maybe you can get a factor of 10 if you do it that way. I don't know. I'm not gonna do it. I'm too lazy. I just want to power through these problems that actually make them fast. I guess doing an NumPy got me a factor of 150 because Python is extremely slow. So I guess that's some optimization for you if you want that. But yeah, that's all I'm gonna do with this problem. See ya.